So hi, Sean. Welcome back to Airhacks FM.
Hey, thanks for having me back, Adam. It's great to see you.
Do you still remember when it was the last time at the show?
2 years ago?
Yeah, it is even, I think, 2018 in January. So it is
Okay, so it's
3 years.
Three?
Yeah.
Wow, it doesn't seem like 3.
No, but it's crazy. This is episode number 5. So I just double checked that, but this is what, yeah. Sean's,
I was on 5? That's pretty good.
It's crazy. So it is January 31st, 2018.
Yeah, you just see, the problem is that like time just flies too fast, right? Actually, this whole last year, everyone knows the whole last year is like, it's still March, right? It's March again. It's never stopped being March from last year.
Yeah, and it is really, it's crazy. So my problem is with the pandemic, I underestimated the productivity on airplanes. You know, I said,
how useful you were on airplanes?
Yeah, but what I thought is, with the traveling, there's lots of dead time. So I basically said the last year to everything, yes. And then I got lots of projects, lots of conferences, and it was crazy because usually what you are doing, you can schedule the talks between conferences, but in online conferences you could actually deliver a talk, every day. And the problem was there was no dead time between, so it was really a dense time the last year. It was just crazy for me, and I got also thankfully a lots of real projects. And this was just crazy time. So this year I'm going to be a little bit more careful. So I will say not always yes. So this is.
It's almost worse with the virtual conferences, right? Because there's no travel. So everyone thinks you can, like, you think that we have more time. Like you said, actually, it's pretty much we had the same experience.
Yeah.
It's like go, and then the bad thing is, the in-person conference experience is personal.
Yeah.
And so you give a talk, it's always different. You interact with the audience, you get the feedback from the audience. People have looks in their eyes like they don't understand what you're saying. You can read this and sort of maybe you go in more deeply. And online, it's like every experience is it's the same. Like it's a blank wall.
Yeah.
It's there's been discussion of, is it ethical to submit the same recording to multiple conferences because it won't be different.
Yeah.
Right.
But right now, so last hour there was a German session, and there were about, I think, 100 attendees. And what we did, they had they camera on, and this was very good because we had this even better interaction than at conference because they ask more question. At conference, there is no more distance between the speaker, and on online, everyone is the same. So I did the opposite in workshops. It works even better because there is no difference between me and the others. They just asking question and they get an answer from somewhere. And at conference, you are always looking down to the to the audience.
So we're thinking we're trying Twitch out. We're trying to use Twitch more.
Yeah.
And similar thing, right? This is the chat. So people can start asking questions.
Yeah.
And anyone can ask. And I think maybe it'll loosen up people to ask more questions.
Yeah.
And interestingly, it also becomes less formal. So we're experiencing that, right? So we have opened up, like we have these regular internal, like just tech talks, from component leads in the GraalVM project. And so we put them on Twitch. Like it's just, we're just sharing like what's going on. Nothing's secret, proprietary. And I think that's good because it engages people. People are more relaxed because I'm kind of tired of these more formal, corporate-y, presentations. I'd much rather just chat and it's more information comes out like we're doing now, but on the Twitch kind of approach.
But you were always, this kind of speaker. You never delivered a high-level management talk, right?
No. I mean more the sort of like, please present a webinar on this topic. Right? A corporate. It's kind of like it's not scripted, but you're still doing it yourself.
Yeah.
But it's still kind of, there's no audience. You're just recording it.
Okay.
Or you're broadcasting it and the audience out there somewhere, right? Not the same as.
Yeah. One conference last year, I said yes, and they asked me for pre-recorded talk. This was the only time I did it. This was the worst experience for me, because a live talk, something can go wrong and the attendees can help you, and this is like live experience. But if you deliver a talk upfront, I tried to do something different because I have more time to preparation, and I think I pre-recorded a talk like 5 times or 6 times, and it was the the worst experience ever for me. And then I watch myself at conference and I say, never again. So if I will never deliver a pre-recorded talk again. And I think this is like cheating because the attendees could ask me questions, but usually I can react during my talk to the question. Right. But they ask me question and we had to stop. This is not even possible. So I don't get it and I don't like it, I have to say. And there's really no difference to screencast, I would say.
I learned a trick though for myself anyway, which was we did a broadcast to customers, and when you pre-record, you want to be perfect, like you're saying. You sit there, you spend many hours, you fix it. I put myself on camera, and then I put my picture in the presentation, right? So this is common enough, right? So you have the presentation, and I do it in one take. So I'm just talking, and so I can say something and go, no, let me rephrase that. Like you realize you misspoke a little bit. And so it freed me up. So now I'll just do it in one go. I don't feel like I have to be perfect. I don't feel like I have to edit it to not mistake, because they can see your face. They can see you go, oh, no, that's not quite right. Let me rephrase that. And so I felt way better. It was way more productive. Put your face on the camera in those presentations, and people just accept it as, you're human. You're gonna speak like a real person, rather than having these perfect, packaged, error-free deliveries.
We did another pre-recorded talk. So there were actually two, but this one I knew better. And this is Drive-In Conf. It was in Sofia, I think. And the guy who did it, he joined Oracle recently at the Helidon team. I forgot his name. And a nice guy, Java user group guy, and he asked me, can we pre-record the conference? Because this is a drive-in, so really drive-in. This was Corona pandemic, so the people came with their cars. They showed me the video. That's crazy. This was this was crazy.
That's good.
That's good. And he asked me to pre-record because he was afraid about there was a huge display, and he was afraid about the connection and stuff like that. It's okay.
Sure.
And what we did a pre-event. We invited a couple of people, and we pre-recorded a live event. Up front.
Okay.
And this worked perfectly because we had an audience of 10 people and they asked me questions. And this was for me, I didn't care whether there were 1,000 people or 10. And then we submitted a talk to the conference, and this was fun. This was a nice hack.
Did you speak at Jax in Mainz this year?
I forgot to register.
They did a hybrid. They did
a
half.
Yeah. Mm-hmm.
Yeah, they had people there. I know that Wolfgang Weigand was there.
Yeah.
And they had some people in the audience spread out.
Yeah.
And then others were online. So I guess it gives you both. It's both, right? It's
hybrid. So I was there, but I forgot to register for this year, Mainz. Yeah. So this was the first time in my history, which I didn't attend the JAX. We met at the JAX, I think, the first time, or the Java one, I guess. You were the Eclipse guy, and Eclipse Link.
I don't know.
Yeah.
Yeah, it's a long time ago. I don't know, right? It's like forever.
Yeah. Hey, what happened with FN Project? So last time we had a lot of chat, with serverless and FN Project, and a little bit quiet. So I look at the GitHub, something happens, but it's not like, it is not like it's taking off.
So I haven't been working on that since October 2019. I know the team has mostly spent their time on building the service side of it, right? So I don't think so. So they're still using the core, like they're still. The code that's in GitHub is still being picked up and basically used for the service. I think most energy is around the service issues because it's easy. Building this core serverless platform is one thing. Building it as a globally scalable, reliable platform is a totally different experience. It's like 90% of the work is actually the service side. The execution, that core engine, is not the hard part in some strange way, right? And I do know from when I was there, just as service was coming online, we have a thing called the platform bar in Oracle Cloud Infrastructure, which is all the things you must do before you can be a service. Mm-hmm. And that's a big list. Like you must have tags you can search, so customers can tag a function, tag anything, and then search it from anywhere else. Like all these are sort of servicey integrations, and that just chews up like months of time. So they did do that, but I know they're working on internal stuff. I don't have the inside story on what their plan is, but it's a real service, right? So it's been gaining ground in terms of customer acceptance. So it's not dead, that's for sure. In fact, it's actually a critical service because like the Gartner sort of cloud matrix, which everyone likes to go for, has serverless as one of the key components of that platform. Mm-hmm. So every cloud provider has to have one. So they're certainly not like Oracle's lost interest. It's just that they're focusing on internal issues versus external issues.
I can imagine because right now in my project, I have a Java backend and I push it to the cloud, and the most time which is consumed by certificate management and networks and network translation layers and this was like what the plumbing we did 20 years ago. Now it comes back a little bit more automated in the cloud, so it is like actually crazy what do you have to do to put something in production?
Yeah. And then for them, as part of a cloud ecosystem, you have all the other services you
Even
have to
worse
connect
for
to.
you is even worse because you are actually have to control the infrastructure, right? So I'm just saying, I would use Cider with the subnets, but you have to actually to do it. So you have to to control the routers and all the plumbing. This is even worse.
Right, because when you deploy a function, there's virtual network interfaces that are being allocated, attached to things. Oh yeah, that's all automated, right?
Mm-hmm.
But no, it's the engineering work of serverless. Like you look at AWS, you look at Lambda. The key thing with Lambda is you can call it from anywhere. Mm-hmm. They've done it, like it's been around a long time, so it's fully integrated into everywhere you go in AWS. So that's part of the work is, okay, so what if something happens like the notification service on OCI? Someone has responded to some event. Well, they should call a function, right? Mm-hmm. So there's building that bridge between those services. There's some data appears on a Kafka queue. Okay, we want to call a function to process it. So all those integration points, and really it's not point to point. It's better than that, but that's a lot of work, right? So service integration becomes another huge piece of it, which again you don't see in the open source repo because it doesn't really matter.
Yeah. And so what I observed with lambdas and functions, that they are actually starting to be used properly. So 5 years ago, as Lambda started, it was just craziness because what I saw is that people try, to port or migrate their monolith to lambdas. And this is just crazy. So instead of having a nice Java classes, they had millions of functions and no one knew what actually happens. But now people starting to be more reasonable, developers. And what I see is that the lambdas are used more like integration point, which makes absolute sense. More or less like
responding to this,
like message-driven beans almost, back then. So something like this makes absolute sense. So I'm for it.
Queues, right? And functions are exactly what you say, right? Like just like if data appears, please process. Yeah. But often, and I think you're right, it's often the glue code between all these other things you're trying to build. Yeah. It's like a little piece of code needs to run somewhere. We saw this with Oracle Oracle Fusion applications. Mm-hmm. So you can use Visual Builder Cloud Service, for example, like so build a GUI, and you need some logic somewhere. Like there's a place for logic. Like where do you run logic? In the past, they would have spun up a WebLogic instance and done that. Now you can use functions. So just some random bit of prefetching, caching data, processing, even doing things like I remember there's an address translation function which you'd think would be standard, but it wasn't built in. So they had to call some logic. So functions are perfect. Just like run a piece of code.
And what's interesting is the functions is they are consuming some kind of data, and there's usually a proprietary cloud API, which is byte array. So this actually an FN function project did the same. There was like a byte array, but what starts happening is you can actually have a JAX-RS resource, which is indirectly called by a function. So what you could do actually, you can actually deploy a JAX-RS, let's say Jersey service or microprofile service, Halidon or whatever, or a micronaut, which is actually a function. So it doesn't make any difference whether it runs as a function or as a container service. And this is interesting.
Yes, and we had actually had support for that way back in FN. We had done some support for JAX-RS support, and it doesn't quite fit the model because you've got multiple entry points, right, in the in your bean versus one. But Micronaut, if you look at the Micronaut work that that team is doing, they're working hard to take that your function, your piece of code, Micronaut program, and basically expose it via functions, via whatever. They're definitely pushing in that direction. But yes, it's just exposing the functionality via different entry point.
Yeah,
they want to make it easy.
You quit the FN project properly or department, and now you are. What are you doing now? So
I left the cloud. I got out of the cloud. So I'm one of those people who, I'm
to the sun, from cloud to back to the sun, right?
Basically, yeah. So I'm working in Oracle Labs, which used to be Sun Labs. It's true.
Okay.
In the history, right? Yeah. So Sun Labs evolved into Oracle Labs, and I went over there and to work on the GraalVM project. Mm-hmm. So this is really a sort of more going back to more original interest, more core Java, right, versus application like services. Mm-hmm. So in my career, I've always been working on developer-facing services, right? So Eclipse Link is a big one, right? It's always developer-facing. I worked on mobile cloud service, so I went to cloud. Like everyone at Oracle, we were sort of like people were pushed into the cloud to work on cloud. And then Java Cloud Service, application container cloud, which is like Heroku, right? Mm-hmm. Again, always these services, and even functions, they're always for developers to deploy code. Mm-hmm. So GraalVM was kind of going down the stack to like the core runtime, like just running your applications. And I just thought it was a really interesting project. And it's I didn't know a lot about GraalVM even working there before I joined. I mean, I knew before I joined, but for years at Oracle, I had probably hardly ever heard of it. And now I think the time is changing. I think that suddenly it's starting to catch on. That there's this technology that it turns out that Java can be different, can solve new problems, can be faster.
And what's your role yet at the Oracle Labs?
So I'm working specifically on GraalVM. So I'm the product manager leading the product management team for GraalVM.
Ah, okay.
So that's sort of inside outside. So there's a bit of this product side, and then there's open source, and I kind of straddle both sides. We have our own dedicated developer relations team, like Shelly, you probably know, and Alina Urenko, and I work with Thomas Vertinger, obviously. So that's on the engineering side, and I'm kind of straddling over towards dealing with that team, and then also dealing with marketing team on product. How do we get the product out? How do you support customers and so on?
What I like about GraalVM is it is like I had already chat with Thomas Wittinger about that. This was like
So everything you need to know. See, I can't add anything.
I forgot a lot of stuff, right? But I always know. There was a blog post. The name of the GraalVM, the origin name was the project Maxwell. Maxwell first, and then was renamed.
Really, I don't know Maxwell.
Yeah. And Thomas said, okay, this was briefly Maxwell because James Gosling back then, the Java one, mentioned that, and I found the paper and I wrote a blog post. Okay. And then I asked Thomas, I knew about that. It's like, yes, this was Maxwell and then Maxine, and now it's GraalVM. So it's a great story.
Kind of. I think that there's a history there, but I don't know if the Maxine project evolved into GraalVM. I think it's more of a GraalVM came up in some sense of the inheritance of that Maxine project. I don't think.
Yeah.
I don't know. I wasn't here
because they changed the direction. What Thomas said, that they saw opportunity somewhere else, and because the origin idea was to rewrite everything in Java, and then they focus more on the integration place. But first, the interesting part is, this is a little bit spirit of Sun still there. So in the project, and what's really fascinating is this is like multifaceted project. So if you
that's part of the problem is explaining what is GraalVM. Oh, it's a lot of stuff.
Yeah, and the problem is in my project, if I say something with GraalVM, everyone says, okay, we don't need the native compilation. But this is not all about. You can run GraalVM as in the normal mode, let's say, how to call it, in bytecode mode, and you can. You are the product manager. How do
you explain it?
What is the proper name of translation from bytecode to the machine code, or how to call it, the image?
The JIT compiler. Oh, well, from bytecode to machine code is just the compiler, right? This is the thing. So just back up. So this is why
this is not a bytecode. This is not a compiler. This is a transpiler because it transpiles, a bytecode to image.
Well, no, that's what happens inside. That's what happens inside the JVM all the time. So let's back up. So this is what's interesting about GraalVM. So what you have at the core is this compiler. You have this optimizing compiler technology. Yeah. And yes, it's focused primarily on bytecode, Java bytecode to machine code.
Yeah.
Right. So just like C2, the compiler that's built in, or the existing one, right? It takes your hot code and turns to machine code so that it runs faster.
Yeah.
That's what's going on. Right? For the platform you're on. So that core compiler can run at runtime or at build time, essentially. So there's nothing. So when we have the native image ahead of time compilation, Christian Wimmer, who founded that project, he doesn't like to call it a ahead of time compiler, because it's a bit misleading. It's a bit more. It does a bit more than that. But roughly, the flow is native image compiler, or native image utility, takes your bytecode, so jars, classes, whatever. It loads them up into the hotspot VM. So they're there, and then we walk from your main entry point through all the classes and finding all the code you need. But then we run that compiler then, right? So we don't wait till you call the code. We basically run the compiler, generate native machine code. We dump that out and package it into an executable along with a bit of a heap snapshot, because in Java, one of the issues with Java is you may have static initializers that do things at load time. So, and that's a bit of a challenge for us, because if you do something in a static initializer that does something like opens a socket, which is crazy, right? You can't just dump that to disk. doesn't serialize.
Yeah.
But that's so you end up with this. It's the same exact compiler that's producing the runtime, the executable native ahead of time, compiled binary, but it's just run at a different time. So it is one compiler.
Yes. What I mean by that is, this is
Sorry,
exactly
long
confusing.
Yes, it's confusing
because you cannot, tell in projects that we are compiling once to bytecode, and we are also compiling, to machine code. So there should be different names, and how I call it usually transpiler, like in JavaScript. If you have a JavaScript code, even if it's not correct, and you TypeScript to JavaScript, that process is called transpilation.
But you're translating from one language to another language, right?
Yeah. And I know, but
here it's doing real compiler work on the back end.
Yeah.
Because in the Java compiler doesn't do all the things that compilers do. Mm-hmm. It doesn't do all this inlining analysis. It doesn't do loop unrolling. It doesn't do that stuff. It just translates your program into this other format. So it's truly transpiling.
We need a marketing name. This is what I mean,
This is my life. Okay. This is like trying to explain.
Yeah. Because otherwise, I already talking about the JVM mode, or sometimes I even say we are running in OpenJDK mode, that they know this is this JDK, because people.
I just say JIT. I just say the JIT mode. Like you're running in just in time.
Yeah, you try to explain a project lead or a manager that we have a JIT mode. I mean, this for developer. Every developer gets that, but in project they think this GraalVM always it just transpiles or compiles from Java to bytecode and from bytecode to machine code. So this is the main thing.
Yes.
But
it's the third thing, right? So the multi-language support.
This is the interesting part. Yeah.
Well, a lot of people get really fixated on that. They think GraalVM is that, but that's the other thing, right? So GraalVM is just-in-time compiler for accelerating Java performance.
Yeah.
Right? Plain old Java, just Java. The native image utility to generate executables, and then the truffle framework for building language implementations that we can again just-in-time compile the native machine code on JVM. Yeah, so this is where it's
then are four things actually, because truffle is the framework, but they are already ready to use implementations. For instance, I use right now in my project the JavaScript, ready to use JavaScript. You can use Python, R, and even interesting part, the really crazy stuff is LLVM. This becomes to be interesting, and
it is interesting.
WebAssembly.
Yes, WebAssembly is new. We've seen papers from people doing COBOL and PHP using Truffle.
But WebAssembly, I don't know whether you are aware, this is also where the serverless and lambda is going with WebAssembly. This can be huge.
Pressure there.
Yeah,
there's pressure. There's definitely an opportunity there. The reason we have WebAssembly is we need it for JavaScript. So the JavaScript is going to have these, right? So it makes sense for JavaScript. We have a JavaScript runtime. They're going to have these WebAssembly pieces. Mm-hmm. I think part of the specification will include WebAssembly interfaces.
Okay.
I'm not the expert on the WebAssembly for sure, but yeah, it's a growing thing, right? It's another high-level format that runs on a virtual machine almost. Not really.
Really? Because there is a project already where you can run WebAssembly on Kubernetes straight.
Oh, really?
Yeah.
Oh, as the runtime.
Kubernetes is the runtime and WebAssembly is the thing, which is the
right. Replacing OCI, using the container interface to replace, like say, run C with WebAssembly instead.
Yes, and WebAssembly runs on the edges, like not CloudFront, but similar. There is Cloudflare. Exactly. This is the workers, so you can run WebAssembly here. Yeah. And I think for Java, this could be opportunity if there would be possible to now transpile or compile Java code to WebAssembly. This translation, this could be interesting.
I don't know. I don't think we're working on that.
Nine. You are the product manager. You have to promote Thomas. Say, hey, Thomas, look at that, and he will just implement this the next time. But
you already saw that we have so many things going on at the same time.
Yeah.
Right. Yeah. And another one.
Yeah.
So we're working on all kinds of things, right? So there's the native image still continues to evolve, right? It's not done because it's people have issues with it. It's not perfect. We're working with like the Spring team, right? Spring Native to get Spring to work. We work closely with Micronaut because Micronaut just does work, which is great about Micronaut, right? Just because they avoid all the things that are problematic for native image. Because if you're compiling a language, if you had the whole thing in front of you and it's all like this is the code, just compile it. With Micronaut, we get that.
Yeah.
But
we had a deep conversation with Graham Rocher about Micronaut, how it happened. Mm-hmm. A nice guy. And what Micronaut is interesting. because I ignored Micronaut for a long time. The funny story is, I delivered a talk about microservices and I think something with Jakarta or Java micro profile. And the talk was after Graham's talk, Micronaut, and I think even introduction of Micronaut at the DevOps conference. And there are lots of interests, and people ask me, what's my opinion about Micronaut later? And I look at Micronaut. What I really didn't like at all was the proprietary API. And I had a chat with Graham about that. And he said, hey, we support actually JAX-RS already. And CDI injections also supported at Inject. And this happened the last 1.5 years. And what I did, at a conference recently, I played with Micronaut and Helidon. So what I did, I created the Micronaut data integration with Helidon live and explain what happens. And what I really like about Micronaut is the idea with annotation processors. So
yes, that's very powerful.
Not powerful. This is actually, this is the crazy thing, Reflection was used to be dynamic. And the annotation processing is the opposite of dynamics, actually very static. But if it's actually the exact opposite of the first pattern, and you achieve the same at build time. So what Graham does is crazy. He is able to know with the type system, look up to database and see whether this is like exactly what reflection does at runtime. Micronaut can do at build time. And
this is the same as Java. This is like Java. It's the same thing. Is you can defer to runtime, or you can compile ahead of time, right? So and there's trade-offs. There are trade-offs, but it's the same kind of pattern.
Yeah.
Do you want to amortize the cost of your optimization to runtime, or do you want to pay up front?
Yeah.
Right.
It's crazy, right? But you think about this. This is, this is crazy and beautiful at the same time. So, and I asked Graham, are you working in your leisure on Micronaut? It's like, no, Oracle is officially contributing code to Micronaut. I didn't know that. It's like, really?
Yeah. So he joined Oracle.
But what I thought is that he joined Oracle and now he's forced to work on Helidon. But this is not true. He works on a different. This is what I had chat with him. No. It's like I can just commit code to Micronaut and we share some code with Helidon. And this was new to me. I thought his job will be to support Helidon. This is not true. This even 2 departments, right? The Helidon.
Yeah, they're not in the same. We're not in the same group. So the Helidon team are not in the Oracle Labs. So Graham's working for Oracle Labs. He's a peer of mine. So we're working together on things. And there's some good synergy though, because yes, the Micronaut data is really interesting. Yeah. And, I'm a JPA background, so
you're the Eclipse guy, genau, exactly.
Yeah, right. So I'm picking up Micronaut data, and I wasn't familiar. The problem is Micronauts evolved from a different background. It came from like Gorm, I guess the Cradles,
exactly.
And some Spring data, and it was never a Spring guy, right? Really dabbled, but never really embraced Spring. It was more Java EE sort of.
Yeah, exactly.
Background. And so I got to writing some Micronaut data, and I was struggling with okay, how do I do what these finder methods, right? It's magic, right? It's like find entity, and then it would say things like, well, relationships. Like, what do you do with relationships? Like I ended up figuring out how to do a 3-table join, with nullable fields and all this stuff. You have to figure it out because it's not the same pattern. But once you master it, it's very efficient because I can write the finder. It writes the query for me. It's code by convention, right? Or code generation by convention in some sense.
So Eclipse Link very well, and now Micronaut data well.
I don't know it yet. I'm starting. I'm learning.
Do you see some synergies? Synergies is the right term? Because what you could do actually, you could get the metadata from Micronaut and do some crazy internal things with Eclipse Link, by skipping the JPA and just going to internals from Eclipse Link. So
yeah, but see, there's a difference though. The problem is that in Micronaut data, or Micronaut specifically, he's not using reflection in there, right? Or the project doesn't use reflection. So Eclipse Link, we use reflection all over the place. Like typically we would, intentionally so. We didn't want, for example, to call a setter when we built an object from database data. We don't want some business logic firing or something happening. So we were infrastructure. So the object gets built and exists before anyone could do anything with it. That way we didn't do anything, no side effect.
Yeah, but this could be the synergy, because if you get the metadata from Micronaut, you could on the fly create the entities or whatever, right?
But there's no metadata. Well, there is. You can go digging through. Okay, yeah, you could go digging through the object helper objects that has behind the scenes there in Micronaut. Yeah, it's true. But it's still at some point you need metadata. You need a description of this stuff, right?
Yeah.
The micronaut work, I shouldn't say his because there's actually a lot
Yeah.
of people involved, but the micronaut data work is based on this more convention-based
Okay.
coding,
Okay.
right? Whereas Eclipse Link and JPA is there's very few conventions. There's some defaults, right?
Yeah.
So I don't know if it works well. I think the main issue is that if you look at the instantiation of objects, it's just call a constructor and pass in the arguments, right?
Yeah.
And that's pretty much all that you can do.
Mm-hmm.
There's no object tracking,
Mm-hmm.
right? Because there's no injection of bytecode generated proxies to hold values. There's no dirty checking, nothing, right? It's up to you. So it's for me, it's kind of back to the future again, because this was a pattern you saw in the early 2000s. You had other data mappers like iBatis,
Mm-hmm.
you know,
Yeah, exactly,
right?
Uh-huh.
It's similar, and it was like read object and then write it yourself.
Yeah.
And I'm biased, right? The microservices world changes it maybe, right? So when you were dealing with large EE applications, dealing with large data models, they were very complicated with difficult constraint satisfaction or RI constraints. Letting Eclipse Link figure it out for you, order the SQL, and make it all work was really great, right? Anything that over 2 tables, 3 tables, you're needing help. In the Micronaut sort of microservice world, where you're in theory dealing with small table sets, right? It's more like data. Now you're saying, I don't have a large data model. At least you pretend it. And I haven't quite figured this out. This is everyone going from monolith to microservice, right? Large, complicated data model. And you're hopefully dealing with maybe 1 or 2 tables for that entity you're dealing with, right? Then in theory, life gets easier. You still have to be aware of the referential integrity rules and not break them. It's in your face. But hopefully the scope is smaller. The scope of the problem is manageable.
I don't believe so. And the reason is right now I'm actually delivering an app. And the my job is just to deliver the front end with web components as a mobile app. And the back end, I just used microprofile by choice because it's what I know. And I will show you the app, it looks trivial. There's probably 5 views with some state management. But at the back end, I already have, I think, 10 JSON objects. But there's no persistence right now. Everything in static, just as mockup. But if I would map it to database, there will be 10 tables with 1 to n, 1 to 1. So I never saw actually a project with a small microservice with 2 tables. So this is like the wishful thinking.
Yes, this is the microservice world of it's one service with 1 table and they're never connected, and it's not really. I mean, I haven't seen that yet. Right?
Exactly. I can tell you in the real world, if it happens, this is trivial. And what happened in this project, so there was another project, they asked me about microservice. This was a small project. And if you deliver such small microservices in a small projects, it just becomes too expensive. We did the math. Running this in the cloud, this was not Oracle Cloud, but it make a huge difference. So we were, if you would put everything to a monolith, we will pay something like 100 euros or dollars a month. With the microservices, there were 500 because there is an overhead, and
there is overhead.
And
this is where native image helps. Say this is the overhead is way lower.
But what I think the future is, what will happen, this is my prediction for the next 3 years, the microservices become coarser, bigger, and with GraalVM, for instance, it doesn't matter. Because they will start still in 20 milliseconds. You can save money and build, reasonable, not microservice, call it somehow service, self-contained service or whatever, architecture. And this is what I do for years. I actually ignored the microservice trend completely, or I misused the hype to deliver reasonable architectures. So I said, okay, if you can segregate the pieces from the business perspective, we will do it because it makes sense. So but we would never try, to deploy 500 small microservices because it doesn't make any sense.
If you're Netflix, this is fine, right? They know what they're doing. Their needs fit that model quite well. I know what you're saying though. You're doing this practical, right? This is everything though, isn't it always the case, right? New technology says it's extreme, sort of in sense of idealistic, and then everyone sort of applies in a practical manner. They learn the balance between the ideal and then the practical. Same with everything.
But Netflix is not a very good example because if you think about it, they have more or less one product. They have huge amount of resources, And if you optimize just for this product, you have more time, and they do it for years. I think the optimizing. They started with Groovy at the beginning, if you remember, with Tomcats.
Really?
Yeah. And if you have to search a presentation from, I think, Adrian Cockcroft, right, was the architect of
I think so.
at the beginning.
Yeah, he was
and at the beginning of Netflix, there was DVD business and the online business. And the DVD business 5 years ago was still huge. There were several millions customers. And there is on the slides, I have to find the slides, I would put it to the show notes. There is something like, for the view millions customers, we don't care about, the scalability. We just deliver a monolith. And for the, for the online service, this makes sense too, because there are worldwide millions of clients, not just in one country. This makes sense. And the funny story is, most of my projects or my companies I work with, in this project, we don't have millions of clients. So we have probably, this is like an enterprise app, then we have probably 500 clients, And this is why developers go to conferences, look at Netflix, they try to apply, the same ideas in local projects, and they are not applicable. This is complete over-engineering. So like you would try not to buy Formula One car and go to shopping, to grocery. This doesn't make any sense for me, right?
Again, it's about being practical, right? So there is no silver bullet. This is a topic that comes up with this for me. The different modes of GraalVM you mentioned, right?
Yeah.
There is no right answer. There's no one thing is good. There's you have to figure out what your problem is, find a solution for that problem, and find But people would like one answer for everything. There is no one answer.
Yeah, absolutely. Yeah. So in most projects we're running GraalVM in the JVM mode. And where it really makes sense is, of course, serverless. Because if you're running functions, the startup time is crucial, or you have to keep the function warm. So it also happens. And
that's right. And there's overhead for no matter what. Like even if and this is the problem with serverless, even if the program starts in like milliseconds, the service has overhead.
Yeah.
Right. The service overhead can kill you. So there's lots of conversation about scaling out Kubernetes pods, and we should have native image really helps. Like not really, because the overhead of Kubernetes is so much heavier than the start time of the application that it's lost in the noise. Right. It's not a big contributor. So on serverless, on a good serverless platform, it's important.
What's your opinion on Kubernetes? So my impression is it becomes a little bit less popular among companies, and what they try to do is to use a different proprietary orchestrator. What I see, for instance, like Fargate or similar, or Azure container instances, or even pure lambdas or Oracle functions. Does Oracle a similar service to Fargate? Like you can run containers?
They don't have a service right now. They don't have that service available.
Okay.
Yeah. So the container as a service type of approach.
Yeah.
And there's the success of like Google Cloud Run, for example, right? I think they're pretty successful. It was basically that. But again, it's cyclical, right? So again, it's almost Heroku, but not quite Heroku.
Yeah, genau, exactly. Genau is German. Yeah, exactly.
Okay. Yeah, I know. Yeah, I know. But it's like we go in waves. I saw this with. So I was working on Application Container Cloud, which is Heroku-like service. So it's like you just upload your app, right? Like a jar.
Yeah.
We take it, we build a container. We actually use Docker behind the scenes, build a container, and deploy it and open up the ports and expose it on a port. It's like Cloud Run kind of thing. And then that kind of fell out of favor when everyone goes, well, we just all know Docker. Like, why are you taking my code and just packaging it? I want to control the Docker container. Or if you look at Cloud Foundry, right? They have all these build packs that take your jar again and do all the work behind the scenes. And you can control it, but people tend to just use the service. So there was a shift from just take my app to I want to control the world with Docker containers. And now there's a shift back to I want to just deploy my app. There's a definite pendulum swinging between complexity and efficiency, or productivity and control. You give a bit of control to get some productivity, and I see that every few years it swings back and forth.
Well, I always wondered myself, the war was the perfect format, because the war was specified, and if you don't have to go crazy. It could be a subset of Java E. It doesn't have to you can CDI whatever. And if you just push it to the cloud, because this deployment was already specified, so there would be like serverless server in the cloud.
Yeah. So we did this. We actually built this in Application Container Cloud. We had the ability to deploy a war, and it ran on WebLogic actually behind the scenes in containers, and basically it's like you say, we had this. The only problem is that you're missing there is all the service configuration, the service you needed, right? So you need to consume database. You're going to talk to some JMS queue. So all that server-side stuff needs to be declared somewhere. So the war has not got everything in it. You need to have now this what Cloud Foundry had in their service broker. They had the service broker to be able to sort of declare, I need an instance of Oracle database or MySQL, and it would go allocate you one or find you one and wire you together. So this deployment descriptor is also needed.
Yeah, but if you have nothing, let's in the cloud, so you have a war and you push it to the cloud or jar, then what usually happens, you have to, to start your JDBC driver somehow and talk, to RDS or whatever database you have or Oracle database. So then there's no I would be happy, to push.
But you have to have one.
Yeah.
But you have to have a database and you have to know where it is. Or at least you have to declare that you need an instance that meets these criteria or such and such. It goes on like this, right?
Yeah.
But that's why Heroku was popular. Heroku was, here's a jar essentially. Run it.
Yeah.
As long as that jar booted up something that listened on port 80 or whatever port they told you to listen on, it would work.
Yeah.
And they're still in good. They have good business.
Yeah, right? They were bought by Salesforce, I think.
Yeah, they're bought by Salesforce. I think they're focused mostly on people doing I don't know their business. I don't know them, but it seems they've evolved into people who are building apps around Salesforce. So you need some code. Again, back to functions, right? You need a little place to stick some code that goes in front of that big data model behind the scenes.
So what are now the next features we can expect with GraalVM? So now back to GraalVM. You said no clouds, so forget about clouds now towards Sun.
So you're seeing, So in GraalVM, there's some features that are being worked on now that you will see in the next release. So things like we're talking about mult-tier compilation for truffle languages. So one of the tricks with truffle is there's a warm-up cost. It's kind of the Java warm-up cost, and so we're working on ways to provide a faster start. So it's kind of, we pay this price of being on the JVM and being written in Java that we're trying to resolve. So that's actually showing some good results.
Okay.
That's going on. So boot faster. So if you're starting your Ruby program or your JavaScript, it will boot faster, get going faster. What else are we working on? I just saw a list today. We were talking about the features in 21.
You are the list.
I'm drawing a blank. Yeah, but I had the list. Well, I have to ask my engineers. So we have a lot of smart engineers who are cranking out work, right? So it's like, okay, what are we working on? On native image, we continue to work on compatibility. So you keep seeing us adding features. So one feature that's added recently kind of came initially from a PR from Alibaba.
Okay.
For Java serialization. Okay. So you can imagine if you got ahead of time compiled like just machine code, how do you serialize and deserialize Java objects, right? Like we didn't have support for this. Okay. So we had support for that. So slowly but surely native image is adding support. Like we had method handles, so handling reflection gets better. And performance is the other thing. The big thing though for us recently was Espresso, right? So the Java on Truffle announcement. So that was, we've written a Java implementation in Java that runs on our Java substrate. So you basically have a full Java stack.
This was Maxwell, the idea of Maxwell. This
is full circle, right? So if you go on to if you look at our Medium blog, there's a blog in there where Oleg walks through this sort of example of running everything together. Like you can actually take a Java application, compile it ahead of time, and then you can extend it with dynamic Java features, which is really Truffle running like layered on top of this. In other words, hard or frozen ahead of time compiled Java code, and then on top of that you can have this dynamic code through the Truffle or through Espresso. So the example he had was JShell. So you compiled JShell ahead of time, but then when you run your code, it runs on this on Espresso. And it's interesting because you watch the JShell boot; it's a lot faster, right? Because JShell is now compiled ahead of time.
A nice example would be Maven.
Well, Maven's very dynamic, right?
Dynamic.
All these plugins.
Yeah, but core set of plugins could be a core, and the other plugins could be extendable.
That's actually what Thomas has suggested, that a similar kind of thing of this solid core with extensions is Java C. Right?
Exactly.
So so you compile Java C, and then you have annotation processors, which are plugins.
Yeah.
Right.
Very similar. Yeah. I'm just waiting for
It's OSGI also. I mean, I did being on Eclipse and stuff, I did some OSGI, and that's what came to mind to me was, the core platform. I don't know if there's advantage, but right now Espresso performance is not where we want it to be. Right? We released it to say, it's here, it exists. This is really kind of mind bending when you look at Espresso. It's maybe hard to understand because it's Java on Java, written in Java. Anyway, it goes round and round. But we wanted to get it out, and now we're working more on the performance side, right? So basically improving.
What was the vision or motivation to create Espresso? So do you know the vision statement?
Yeah. So if you look at, like I said, there's two worlds, right? There's sort of two worlds. We have the current Java, or the current Graal compiler compiles Java bytecodes. Right? So we take Java bytecode, we compile. And then we had Truffle, which was offering a platform for implementing languages. And in that model, you end up with a Java AST of that program instantiated, and then we can compile that. So those languages that were in Truffle were dissimilar than Java. They had their own little ecosystem, the way they work. They pass data back and forth between each other using the Truffle APIs. And Java was kind of odd. So now with Espresso, we now have a single language implementation platform. Data can pass back and forth between languages with no cost. All the optimizations we're putting into the Truffle platform benefit all the languages. So what's nice for us is when we tune to Ruby, we get the benefits in Python. Right, this kind of stuff goes on. This multi-tiered compilation effort is a result of Ruby start time efforts, which everyone benefits from.
So what Espresso is like adapter layer between Truffle and Java?
It's an implementation of Java using the Truffle language implementation framework. That makes sense. We implemented support for executing Java. So the weird part about Truffle is Truffle looks like an interpreter. So it looks like you're writing an interpreter that we eventually turn into a compiler. If I can put that, that's very vaguely not correct, but the result is as a programmer, you're writing an interpreter, but the end result is we can take the result of that and we can actually compile it like other Java programs down to native machine code. And take advantage of all the optimizations you get from the compiler.
So it means there were already, how to call it, plugs or interpreters for Python, R, and JavaScript.
Yes.
And
LLVM. Yep.
Yeah, and now you did it for Java. So there's not an adapter. This is an own implementation. So you can interpret.
So that's.
So you replaced what you replaced. You replaced part of Java C.
Basically, the hotspot bytecode execution. So the hotspot will be executing the bytecodes. We're now executing. Weirdly, we're executing the bytecodes, right? In Truffle, those bytecodes are the program.
Yeah, this is okay. So this is still bytecode level. So.
So the input from Java, so Java C compiles a bytecode. The bytecode jar or whatever gets run on. So the program is a bunch of bytecodes, right? It's a bytecode interpreter, just like WASM. WASM's a bytecode interpreter. LLVM's a bytecode interpreter. The trick with Truffle, the innovation of Truffle is the ability to make it go fast, right? To turn that interpreter into the compiler. If you think about it, if you just take a simple program and built an AST, so you end up with a big tree of objects. Imagine they are Java objects. They are just a Java program now. So we turned your Ruby and your R into essentially a Java program, which we get the benefits of all the Java tech we have.
For my understanding, my understanding is if you run JavaScript via Truffle on GraalVM, what happens behind the scenes, the interpreter turns this in one point of time into kind of bytecode. So.
No, we don't go to bytecode. We end up with this abstract syntax tree that represents your program. So we end up with a tree that has, plus, minus, and then your numbers, and just a tree. And then we execute that tree. So the tree has execution nodes, right? Like, a loop node, whatever nodes. We execute that. But since it's just Java, of course, it gets compiled down to machine code.
Yeah.
By us.
Yeah. So, you skipped the bytecode. So what happens now is you are able.
Skip the bytecode.
Yeah. So you can read the bytecode and create from the bytecode the tree. This is what happens.
So in JavaScript case, it's JavaScript source becomes the tree.
Java case, this is bytecode. Bytecode becomes a tree, and in Python case, the Python becomes a tree.
Yeah, and in LVM, the bitcode.
And this now makes sense because now for you had an interpreter which read JavaScript code and turned it into interpreted into the tree. And in Java case, the bytecode was interpreted or read. And
right.
Yeah, this is like yes.
But now what's interesting is we now have a common runtime platform for all these languages, right? All the services we have in there. We have interesting things like the ability to constrain resources. So let's say you're in a Java program and you want to run some JavaScript. And this is actually the case. NetSuite does this. NetSuite has they use JavaScript for like user scripting. So the code the user uploads is untrusted code.
Yeah.
Right. Like you got to imagine it's not trusted. So what we added in the 20.3 release was the ability to, and these constraints are actually in the enterprise edition, is constrain the resources that are permitted to that chunk of JavaScript we're going to run. So I can control the time it's allowed to run. So if it tries to do an infinite loop, it's going to get killed. I can constrain the memory it's allowed to use, so I can not let it, kill the machine. I can control the APIs it's allowed to use, so I can really run this in a managed world, right? Because we now own the runtime. We are now the platform for us to do this. So we can do this with Java, right? So think about it. We can do crazy things. We can run Java 11 in Java 8. We can do all kinds of crazy stuff. Yeah, that's kind of mind-bending too, right? Because it's just a Java program. As long as we have access to the SDK libraries and so on, we can do this. So I'm having trouble even putting my head around all the possibilities, right? Because it's just
what reminds me immediately. What you did is it is almost like Docker container.
Actually, my boss talks like this in terms of if we can improve the security guarantees. We need to have really good, strong guarantees. We can let people run Java programs. Imagine an app server, as it were, that runs someone's Java program, but it runs it in a secure manner, right?
Yeah.
Yes, we can start offering security guarantees on some chunks of Java code that maybe is a library you don't really trust.
Yeah.
You want to say, we run it and we have it compute something, but make sure it doesn't do anything bad.
This is like a security manager on steroids.
Yeah, it's on steroids. Yeah.
Yeah. Exactly. And there was a project from Google where they had gvisor, right? This is the project. gvisor. This is what if you're talking about.
It's different.
Yeah, I know, but it's a similar thing. They hook into the system APIs and then they can say is it allowed or not, right? But there's a similar idea.
Right. So it's interesting because gvisor evolved. So I was talking to Ludo Champenois he used to be at Oracle. He was at Google, and now he worked on App Engine. And
crazy, because he was the Glassfish guy, right?
He was a Glassfish guy, yeah. So he was at JFocus 2018 now. Everything's like a year older than I think it is. But anyway, it wasn't last year. It was the year before.
Very briefly, before I forget. So there was a no talk about Glassfish monitoring. And Ludovic was a Java one. And I said, it would be really nice, to have, some monitoring stuff. And we had a brief chat, and he was on vacations. And after the vacations, he said, done. Like, how done? I played a little bit with annotations and now it works. Like, how? And it showed me this and it works. This was Ludovic. Since then, if I hear Ludovic, it's always,
Yeah, there's only one.
Yeah.
Shout out to Ludo. Okay, so he gave a talk at JFocus and he explained the origin of gvisor and why they had to do it. So they were using, Java Security Manager APIs to run jobs on Java 7, I think it was. Or was it Java 6? I think it was 6. And every new version of Java, even point releases of Java, CPUs would come out and it would break their security configuration so that the code could escape, right? So they're constantly working on trying to secure the program within the Java runtime. And then they basically gave up. So they said, okay, we're going to step back and we're going to secure the environment around the JVM. We're going to basically, system calls and whatever with gvisor. And that's why he said there was a big delay between their support from 6 to 7. I think it was the numbers are 7, because they were busy building this infrastructure to contain the JVM, not let anything get out. So now we've kind of gone the other way, which is we've gone into JVM. And it's not it's truffle. So it's not even just Java. It's whatever truffle language, building a sandbox essentially for running these applications. But it's different because you see, we're running the bytecodes now, not hotspot in some sense. Like, there's a layer there, there's indirection. So we have some control.
So what you could do right now is, full circle, something like Kubernetes in Java, right? Because now you could have, like a microservice environment. Let's call it your GraalVM with some runtime logic. And I could just submit bytecodes to your engine, and they're isolated, basically. So I can run on one GraalVM multiple, let's say, super ears or wars, or truly isolated pieces of code, and which they could even communicate with each other over, over protected, secure way. And of course, even Node.js could communicate with Python and then with Java in different versions. This is like multilingual service.
That's sort of, we don't have that service, but it's possible to run those multiple languages and have them all interact with each other. Like you can share data between. Yeah, it's true. It reminds me actually of WebLogic. Remember, WebLogic had introduced some memory protection. I can't remember what it's called now. It was a feature that they had introduced. It lets you run your enterprise application in an isolated memory. The JVM had APIs for
multi-tenant something. There was the
multi-tenant feature. Yeah. I don't know there's a lot of uptake, honestly, because most WebLogic servers are owned by a single customer, right? They're not too worried about the security. But It's actually it is possible, like you say, we could do this. We could contain the code. It's more for, I think it's more useful for dealing with the customers like, or the users like, say, NetSuite, who want to write user scripting. That's really a really obvious use case. A lot of platforms do offer, like use Lua and use different things for scripting, right? We can do it in multiple languages. In fact, actually, you saw that announcement of the GraalVM and the Oracle database.
Yeah, this is
the same idea.
also nice.
Right. Yeah, it's still truffle running JavaScript basically on GraalVM.
But you could always run different languages on JVM. There was the spec, the scripting spec, JSR, for, the name, the number. It was
no, but invoke dynamic.
Not invoke dynamic.
Support, right?
It was prior to this. It was introduced to JDK 1.6, the scripting API for Java, where you can just say
familiar, but
script engine, where how NAS1 was, injected to Java, and the main problem was that the metadata was not compatible. So you couldn't just call, from one language to another, and this is what GraalVM solved, right? So this is where you can the metadata for all languages is the same. So you can basically call out from Java to whatever you like, which runs, And this is
so you've seen the debugging demos, like in Visual Studio Code, where you step from one language into the next, and you're still in the debugger.
Yeah.
And I remember like a long time ago going from Smalltalk into C code, right? So you're in the Smalltalk program, you're debugger, step, and suddenly the C debugger takes over your Windows machine, like your DOS machine, whatever it was, Windows 95, I don't know. It would pop up, and suddenly you're in the C debugger, and it was really weird. Then then you go back, and with this now we have C code, Java, Python, whatever. You can stay in the same flow. You can debug across. You can see the data structures. It's much more productive.
And what's about mission control? Is it somehow integrated? It's Java mission control?
No. There's Visual VM. In our team, we manage Visual VM, but not mission control. Yeah.
And Visual VM, is this special support for something, or just?
It has some support for GraalVM. It does have support. So it comes with GraalVM. So if you get GraalVM, you can get the Visual VM version that has the extended functionality.
Yeah, this is exactly on one of the pro tip, because this Visual VM is decoupled from the JDK right now. So if you download OpenJDK, whatever, this comes without JVisual VM. What I do, I have GraalVM on my machine, and I would like to launch, Visual VM for my performance tests. I switch Java home to Visual VM to Graal, and I get my JVisual.
Okay, that's a good story. I could tell that story. When I want to debug my code, I use GraalVM.
Yeah, I have even on my machine JG11, and this switch to Java home to GraalVM, so I can open. Yeah, and another story is JavaScript comes with lots of interesting libraries. For instance, templating. What we did with GraalVM, just straight Java application, and for specific cases like user scripting, we're able to load mustache or handlebars, and this mustache on handlebars looks like JSPs, but this is well known by the developers, and we got back the template, and we could display invoice or whatever, and it works. Actually, the interface between Java and GraalVM's JavaScript is really easy. It's like 3 lines of code, and you have it.
So you're basically using the mustache. You're using the JavaScript libraries to do the templating work for you that your main Java app was serving up.
Yeah, exactly. This was a micro profile app, and it's actually even part of my course last year. And because this was very common, how to create invoices or whatever. We did it several in projects. Okay, show it in the course because it's fun, and use the GraalVM JavaScript. And the cool story is, I forget to switch it back, and what I didn't recognize that actually GraalVM executed all my npm and all the builds. And it worked perfectly, but in one point of time, I just said, I forgot npm version, and I saw some more GraalVM. It's like, why GraalVM? What's? And I said, oh man, 1 year, I even didn't notice that everything was executed on Java, all my JavaScript code, which is cool. Ask, the Thomas.
All your Node code is running on
and GraalVM. No, I don't use Node on the server. I just use, some transpilers, rollup and stuff like that, which transpile, the proprietary JavaScript code to web components, whatever. And this run the entire infrastructure on Graal without any problems, which is amazing.
That's awesome. That's amazing. Actually, so were you running this JavaScript code on using on GraalVM CE, or were you using OpenJDK with the GraalJS library?
I downloaded GraalVM as a project, and I created the native image because I wanted to test it, and then I don't remember, I installed the JavaScript runtime, or it was already there.
Yeah. Okay, that's good. I asked because the performance performance of these languages, like with truffle, really there's a couple between truffle and the compiler. The compiler, they're tightly linked together.
Mm-hmm.
I mean, it does work. The interpreter works without the compiler, but you'll get terrible performance relative to like using the Graal compiler.
Okay.
So the Graal compiler is specifically, like they say, it's symbiotic, right?
Mm-hmm.
So the performance, like we don't even like people say, oh, can I run GraalJS on OpenJDK? Well, yes, but we don't recommend it because you're not going to be happy with performance because it's just an interpreter that, written in Java. So it doesn't really get you a lot. With the Graal compiler, it sees that code, knows what it is, and goes, "Oh, I'm going to compile that."
Mm-hmm. Yeah, and I used Maven dependency was like GraalJS as well. So exactly, and with the Maven dependency, I got the entire support for that. And there's one issue where I missed EJBs, stateless EJBs. You can imagine, right? The problem with the EJBs would solve this beautifully, but there is no solution in microprofile because microprofile doesn't have pooled scope. There is request scope, session scope, whatever. The issue is with EJBs, what I could do is I could launch the GraalVM context in post-construct, then say we have 10 beans in the pool, and then we get reused. If you don't have EJBs, you will have to implement the pool by yourself, which is not trivial. Because you cannot, two threads cannot meet inside the GraalVM because this is not multi-threaded.
In which context?
In none of GraalVM context, in the JavaScript context. The JavaScript context is single-threaded, so you will have.
Yeah, there's a blog about this from our team on dealing with async and sync interactions. You can do all kinds of clever tricks.
Not that. What I'm talking about, imagine you have a Java code,
yeah,
and Helidon code, and you would like to call, the mustache from JavaScript for rendering. So if the requests come in, you have two choices. You can boot, the JavaScript context and tear down, or you could actually keep it alive because, booting the JavaScript takes some time. This is not trivial.
Yep.
So there is no way to do it because if you don't have EJBs, you cannot pull easily, the context.
Can't let it sit around. There's nowhere to put it.
Yeah. So I already thought about, to create my own pool or whatever, because I didn't want it to use EJBs, even if it worked, because in this particular course, I would just focus on microprofile just for fun. And this was not actually a hard problem to solve. Of course, you could, have a kind of queue with a singleton, whatever, but, with EJBs, it was just one-liner. Without EJBs, is problematic. That's where a pool becomes interesting again.
See, EE wasn't all bad. Right? Now think, people look back and go, "Oh, it's terrible," But there was some good and bad. I find it strange that JPA was in the EE spec. Even I find that strange now because it was developed in that, but it has nothing to do. It always worked in SE, no problem, right? Just plain old Java. Yeah. But for whatever reason, it's part of that world. I don't really know. I'm not sure how they decided which belonged where. I think the Java spec wanted to stay small and lean, and not contain a lot of clutter.
Yeah,
that's the main issue, I guess.
So, what else? Anything to add with GraalVM? Interesting?
Well, the whole thing's interesting. That's what I find interesting. Yeah. Yeah. It's really interesting to see people. Well, the biggest thing is I think that people are confused mostly because it sounds like it's a different thing than Java. And most of my time is trying to dispel the confusion. Like, no, look. There's two different distributions of GraalVM. There's enterprise and community. Community is basically an OpenJDK distro, and we plug in our compiler. Yeah. The Oracle GraalVM Enterprise Edition is we take the Oracle JDK distro and we plug in the Graal compiler, and that's basically it, right? But I'm trying to dispel that problem now to just try and clarify what is this GraalVM thing, because it sounds like a mysterious collection of, like you say, there's so many things it does. It's an umbrella, right? So GraalVM is a project, not a thing. As it were, right? Because it does all kinds of stuff.
One question regarding community versus enterprise. So is the community somehow restricted? I mean, am I allowed to use it everywhere? This is a common question for my clients. So now I know the question.
It's GPL. It's the same license as OpenJDK, right? So you take a look at the license.
No restrictions. I can do whatever I like with it.
You can do what the license lets you do, right? So if I were a lawyer, I would say that. Yeah. So whatever the license is the OpenJDK. You'll see the license is GPL plus the extensions.
Right? Yeah, but the license is the same as OpenJDK. So whatever I can do with OpenJDK, I can do.
And we have to, right? We have to for
very common questions. I wanted to hear, from product manager. Yeah. So this is.
Yeah, and enterprise is obviously it's a Oracle license. The differences are significant in terms of performance. So there's quite a few optimizations for JIT applications in the enterprise edition. There's a lot more optimizations because that's the difference. So the core product is pretty good, and the enterprise is honestly better, right?
So, can a client start, let's say, with community, and they decide for critical workloads they would like to migrate to enterprise? So can they just pay for the same bits, or will they have to use different bits? So they will have to download something different, right?
They should download the different, yeah, because there's performance enhancements in the enterprise bits.
Because they're using Oracle. JDK.
Yeah, I mean it's the same. We basically have additional optimization phases and so
Secret
on
sauce
in the compiler. Yeah.
And how much faster is it roughly? Is it like?
If you take a look, it's significantly faster. If you take a look at Renaissance.dev, which is a website where they're benchmarking, you'll see the numbers. CE should outperform OpenJDK in all cases. And if it doesn't outperform OpenJDK, then we consider that a bug. That's basically our position.
Not CE, EE, you mean, right?
CE should outperform OpenJDK.
Okay. What you're talking right now that the community edition, GraalVM, is faster than OpenJDK.
Yes, and we have seen this from even large customers who've done benchmarks. They see improvements with CE. So that's good. EE is significantly better, though. Significantly better.
Better than CE. EE is better than CE.
A lot better. So if you take a look at the Renaissance numbers, you'll see that in some cases CE is slightly better than OpenJDK. Like it's a minor. And part of what's really interesting about this is that there are different optimizations in the C2 compiler than in the Graal compiler. And what I've learned on the project is all these optimizations interact with each other. It's not like we add one feature and it works alone. It's usually what order the optimizations take place in is something that the engineering team looks at. Sometimes they'll change the order the optimizations are done in, and that will affect behavior. Like, do you inline first and then do something else, or do you do the inlining after you do that thing? These have big impact. And so yeah, Enterprise Edition has a number of other optimizations, and then the ordering may be different, and the code we produce is quite more performant. They're also the other thing that people don't talk about is basically efficiency. So when I joined the project, I definitely thought about, performance, or GraalVM is about making applications go faster. But also it turns out that part of going faster is also being more efficient. So we don't generate a lot of garbage. There's way more aggressive inlining of code, which can make the code a bit bigger, but the performance is good. And also we do a lot of object elimination. So we don't allocate objects that we can get away with not allocating. So there's a feature called partial escape analysis. So escape analysis is where you're looking at a method and you can see some object is allocated. And if it's never used outside the method, you know that object doesn't need to go on the heap, right? It's local. So even though you say new foo, it's just local stack.
This is the reason why you should never pull objects, right?
Pull object. Yeah, yes, pull. Well, pull, but it makes sense sometimes. Okay, it does make sense. But let's say that you have a method and it has an object foo, and you pass foo to another method, right? It's escaped. At this point. So now a dumb compiler would look at that and go, oh, it left the context. I can't tell how long it lives. I have to put on the heap, right? With us, we're much more aggressive about this. So we'll do more inlining and we'll do a partial escape analysis. We will look further and see that even across a number of methods that really only lives this short lifespan, therefore stack. And better than that, if you only ever use let's say it's a person that has first name, last name. If you only ever use the first name, there is no object. It's just a first name. Right? So there's a lot of the compiler does terrible things behind the scenes that you, as a Java user or as a programmer, you're thinking that makes no sense. But really, at the compiler level, it's fine.
This would be perfect marketing line, This GraalVM EE compiler does terrible things, It's
terrible things behind the scenes.
Yeah, this is like great stuff for the T-shirt.
It's funny because you're talking with the engineers, on our team, to them this is like normal stuff. We're going to unroll this and we're going to eliminate that and we're going to change the order of the instructions. And you hear this all the time about Intel, even Intel machines, these parallelizations and the clever loop. Hardware and compilers do terrible things that make your code go faster and you don't care, right? In theory, you don't care as long as it works, right? It's fine.
Any other features for AE besides performance? So like
a lot of features in native image, actually.
Okay.
So native image has G1 garbage collector. So the G1, the CE garbage collector is not at the same level of performance as say G1. But that's a big deal. If you do have longer running applications, G1's better for sure. There's a feature in enterprise native image called isolates, which is basically we allocate, like the workload can run in its own isolated heap space and class space. So nothing that happens in that space can get out. So I keep thinking that for function, this is a really interesting feature, and I never got to implementing it. And I kind of suggested to Graham, this is an interesting idea, that if you receive a request and you've got your function's hot, so it's up and alive, and it's servicing multiple requests. They're coming in, right? So if you put something in a static in one request, the next request could read it. And this is what people do with database connections. They kind of cheat. They stick a database connection in a static. It's iffy, right? It's a hack. Right? But with isolates, you can ensure that the incoming request gets handled in an isolated space. And then when you're done, you don't even need a garbage select. You just deallocate the entire space. Like it's just gone. It's a nested VM in some logical sense. You have a nested VM to run that request, and then it's gone. And this seems like a really good use of for functions, especially like reusing the same virtual machine to run jobs in a clean way, right? Clean every time.
Serverless.
Yes, for serverless. So this is an isolate.
It is not serverless. It is VM-less.
I don't know.
Yeah, and what I'm saying is that actually inside the VM you can have something which lives within
like a nested
request context inside a request, and the parallel requests are isolated, and after the request everything is gone, and you call it isolate.
Yes, so that there's an API there for basically creating an isolate and then running some code in an isolate. And I was suggesting that. At first, I was going to try and get this pushed into the FN FDK. So at some point, you provide some Java code, right? And then there's a wrap that the function developer kit from function FN basically runs your code, right? Like it basically when the request comes in, it receives a request, it finds your function, invokes the function, passes in arguments. That wrapper code could, in theory, run your whole function in one of these isolates if it had if it implemented that. But it couples you to the GraalVM API, so it'd be a version of the FDK perhaps. And I know that I spoke to Graham about this, so something Micronaut could do the same thing for you. It could just hide it from you. You could declare, I want this code to run, or this request to run in an isolated environment, and then it makes it happen. So it's an interesting idea if you make it more declarative, basically.
What Graham told us already, that Micronaut is actually not only Oracle commits to Micronaut, but also Google and other companies. It's actually this was for me a new. I thought this is like Graham and some friends are committing once a week, but it's actually an interesting project. No. Yeah.
It's ongoing. Yeah. And in fact, the team at Oracle has expanded, so we've grown the team with more committers. And Google contributes. So everyone wants these things to work on their platform, right? It's just the old, if you're a database vendor, you want to make sure your JDBC driver works with that platform. Yeah. If you're Google, you want to make sure that when deployed to Cloud Run, it's going to interact correctly with the Cloud Run platform. Yeah. So this is good. I think this is really good. In fact, Micronaut does a really good job of abstracting out those platform interfaces from you. So moving from one platform to the other should be easier with Micronaut because they're doing the work for you.
Back to GraalVM CE. What is the reason just to use OpenJDK? Why not always use GraalVM CE then? Even if I don't need all the features, I could just use GraalVM just to run my regular workloads.
Yes. So GraalVM CE, the JIT, hotspot is OpenJDK. Is OpenJDK.
Yeah.
We get a build. We get the fixes.
Yeah.
We plug in the compiler.
Yeah.
That's what it is. Exactly. Right. So why wouldn't you always use that? I know.
Yeah.
I asked you the question as a user. Why wouldn't you opt for the better compiler?
Yeah, and I have to take a look at the Renaissance.dev because what I'm interested right now is that the comparison between OpenJ9 and GraalVM CE.
I don't think the numbers are on there. We have done some internal stuff.
Okay. So officially, no one listens to the podcast. So is this some?
Okay, it doesn't look that good.
Okay.
OpenJ9. Sorry. In terms of the benchmarks we saw, we did actually run Renaissance.
Okay.
On it, but we ran it internally. We want to know. We had a customer who was running on that, and they wanted to know, how do you compare? So we ran it ourselves, and it wasn't public, but anyone's free to take the Renaissance benchmarks and run them themselves for sure. Exactly. It's open source.
So is this this GraalVM is as a competitive to OpenJ9? Let's say this way, right? But
yeah, absolutely. Well, certainly OpenJDK is competitive with OpenJDK. Yeah. So we're going to improve that gap on top of OpenJDK. Yeah, I mean, it's an interesting world. There's lots of innovation going on all over the world in compiler staff, and our people it's a small community. You know what it's like, right? Everyone in the community, certain communities know each other. So people will discover something in Facebook has published a paper yesterday on some topic, and everyone went, "Oh, that's interesting."
Okay.
And so everyone learns, and then the industry moves together, moves ahead. So I think we're one of the few organizations where we have like a whole collection of compiler engineers working on this problem, right? So it's a unique place to be for sure.
Yeah, perfect.
It's pretty cool.
And the last question, the last full circle, is are you aware of Aurora VM?
I've heard that name. What's Aurora?
Yeah, I was fascinated by that probably 15 years ago or more. This was Java on Oracle database. You could write around, I think it was around 1998, something like this, before or 2000s, early 2000s. There was Aurora VM, and you can search for Oracle, and you could run stored procedures in Java.
Oh yeah, but that's just Oracle JDK, JVM embedded, right?
Yeah. But back then,
slow though, right?
Yeah, it was slow, but I was a Java fanboy, and it was fascinating. Okay, now you can write, stored procedures, Java stored procedures in the Oracle database. So for me, it was huge, and this was
we looked at it.
Aurora VM, and now we have GraalVM. This is crazy. So can you write actually stored procedures in Java, which runs as GraalVM on Oracle database?
Today, no. Today, the support is for JavaScript. We started with JavaScript because that was the language that most were interested in.
With Espresso would be technically possible, right?
Yes. But Espresso is not there performance-wise, so really it's not practical. But the JavaScript performance is good.
Okay.
Python makes sense, right?
Yeah,
but we started with JavaScript. Started with JavaScript. There's a couple of blogs. I'll find you the links for maybe the show notes. There's a couple of blogs on the feature's called MLE, multi-language environment. So the database has their own name for this feature, powered by GraalVM, basically. And the blogs cover both writing stored procedures in JavaScript, and then the other blog covers Apex apps. So you can imagine this is very useful. You get someone out of school, do they know PL SQL? No.
Yeah.
Right? So they want to build web apps on top of the database. Okay, here's this Apex framework. Your scripting is in JavaScript. You can easily get access to data. This is way more palatable in the 21st century than the PL SQL solution for Apex. So this is the big use case for sure.
What I had to do recently is, to implement a hook into the Golden Gate. So it's like the
I know Golden Gate.
Yeah. And what happens behind the scenes, you can capture basically database tables, which the events are stored in a kind of queue, and you can pick the data from the queue via JDBC. And what you could do actually with GraalVM, you can listen to these events with JavaScript right now with GraalVM. So it technically would be possible. I don't know whether you are there, but what you could have, you can say, these are my data tables, and I'm interested in the events. And then if something changes, this JavaScript gets called, I get the data, and I can push the data somewhere else. So this is...
Sadly, you're unaware of this thing that I worked on, that I built. I prototyped it, and then we built it, called Hot Cache.
Okay.
Which was coherence and Golden Gate and Toplink.
Oh.
And so the idea was, we used the old, I think it's evolved now, it's Golden Gate. We used the Golden Gate client library, or client, which had an embedded JVM. In there, we ran a Toplink application that ran backwards. It did ORM backwards. So normally you're in a Java application, you play with the objects, it creates tables, right? And those tables. In this case, we took the mappings for Toplink and we flipped them, JPA mappings, and said, okay, when the table changes, which object is that? Which column, whatever. So we figured it out. And then we would tell coherence, hey, the cached object you have in database is now either invalidated or we'd update it. So we ran a coherence client. So we were pumping changes from database right into coherence cache.
Yeah.
And it's still available now. You can get it today. It's part of coherence offering.
This is why I always ask myself why the JDBC driver is unidirectional. I always why you cannot subscribe to changes in the database, and you implemented that, right?
Well, no, we use Golden Gate to do it.
Yeah,
right?
no problem. Yeah, but from the whatever, however you call it, but it's the same effect. So I can actually watch.
Same effect.
Yeah, I get
watch
called.
The database.
Watch the database.
And because the problem with coherence and all these middle tier caching layers is that they get stale. And you can't eliminate it, but you can reduce the staleness, right? The time they're stale.
Yeah.
So by proactively pumping data up into the middle tier on change means that the caches are more reliable. You're less likely to have an optimistic log failure, basically.
We had lots of conversations about that. So back then I also used the cache coordination from Eclipse Link to minimize the effects of optimistic log exceptions. Interesting. But this has some legs because I don't know whether you are aware about the project called Debezium.
No.
What Debezium is a huge. What Debezium is, it's a open source project where you can subscribe for Xstream changes. So Xstream is the Oracle. If you have Xstream, you have Golden Gate basically. So you get Xstream with the Golden Gate license, and I think behind the scenes is exactly the same. So you can subscribe to a capture process. And what Debezium does, it transforms the events into Kafka.
Oh, really? Okay. Oh, yeah. Well, makes sense.
Yeah, and because Xstream is transactional, you get actually nothing gets lost, and they know the SCN, so which commit it was, and they pick the data and put it to the topic, and then you can it's the entire database, the histories in the topics
is in there. It's like a transactional log almost.
Yeah, and with JavaScript you could with GraalVM could be between, and then we could say okay, we can transform the data whatever. So it's parts of the Kafka in the database, right? Crazy.
Yeah, well, that's yes. It's always remixed, right? It's like
And this is people say Oracle is boring, and after the conversation, you see this is still, in some departments, it's almost Sun Spirit, right?
We like to believe so. The team is operating pretty much in the open source and open, right? There's obviously some corporate work, but mostly it's happening out there. You can, we have an advisory board. I don't know if you know, but like GraalVM, we have an advisory board. So we've got Red Hat. Alibaba has joined Twitter, like all kinds of people are on this advisory board discussing, features. We're discussing things like which version of JDK should we support? These are good questions, right?
Okay.
Like the Spring team are on there. So because we used to have support for 8 and 11 right now. And we were getting some, like for us, obviously there's overhead for supporting multiple versions of JDKs because we're having to do backports and all kinds. And so what we were finding is that most people who are downstream of us, like Spring, Red Hat with Quarkus and so on, they're more focused on 11 and up. There's fading interest for 11 or 8 from their side. So that was a really interesting learning, which basically we learned from talking to this advisory board. So where do you put your energy? What are they going to use?
There's no Java 8 in production by projects. Everyone uses 11 and up. That's what I can tell you.
Yeah, but the reality, yes, no, that's okay. But we know, like for Oracle, we have tons of people on 8, right? Like the installed base for 8 is massive.
Yeah, it is massive, but there is no new project with 8. And
right, it's not the new projects.
And with the containers, it is not a big deal to upgrade, to 11. It's not like this is less hard than it was before.
Yeah. So this is the thing. So people who are building, especially native image, this is the main issue, right? That's a new technology. There is no legacy.
Yeah.
Right. So is there any real value in maintaining a legacy, an older JDK for a platform that doesn't have any legacy code?
I would say no, right? But it really depends.
Generally, the consensus was no.
Yeah.
But it's good to have the community comment, right, and have some input on this.
Thank you for your time. And what I would really like to do is to reinvite you back, not in 3 years, maybe in winter or early next year, to talk exclusively about GraalVM. I was just curious what happened, with the serverless and clouds or whatever. And GraalVM is just, I would say, this is a genius project. I really like it.
I think it's pretty cool. And like I say, I've been with the project about not 18 months yet, almost 18 months maybe. And honestly, there's so much to know. Like there's just too much to know. It's impossible at this point to understand all the bits and pieces. And the things you can do. And the problem is you get a demo and they go, we can do this cool thing. And I'm like, oh my God, like on top of everything else we already do, where does that fit?
Yeah. And does Thomas Wöttinger actually sleep or no? He works 24.
He's a night owl. So I'll often be talking to him and it's dark where he is.
Okay.
So yeah, he's up late.
Okay.
I don't know if he gets up. I don't know if he gets up early. I don't think so. But he's definitely up at night. Yes.
Okay. Thank you. Where people can find you? Twitters or whatever.
Yeah, on Twitter. Sean M. Smith, so middle initial, Sean M. Smith. And there's a GraalVM handle. So if you look in there, you might find something of mine retweeted. That's pretty much where I live, is mostly Twitter. Some people use LinkedIn. I know I never really do much on LinkedIn.
No.
But Instagram, not really.
So, of course, you are on Snapchat and everywhere else, right? No.
I'm not Snapchat.
No, what is it called? TikTok, right? The TikTok.
TikTok. We joke about this, saying that we need a GraalVM TikTok channel.
Yeah, of course.
Oh, we're on Twitch. That's the thing, right? So GraalVM,
Yeah.
the team, we're on Twitch now. So it's actually Oracle Labs, I guess, that's the channel we have.
Yeah.
We're trying to do more. So we're doing regular technical briefings, like just with people and also Graham. Graham, I think we did one on yesterday. Just yesterday, we did our first Twitch session where Graham was talking about interceptors, how interceptors work in Micronaut, and he's walking through it, giving examples. So digging in the code is really good functions. So he's giving the kind of all about Micronaut type of sessions, and people on Twitch can ask questions like, how does that work? So it's really, I think Twitch changes things a lot for us.
Yeah,
way more access. It's not like it's like a Zoom meeting, but it's open, right?
Yeah. I will also put it in the show notes. Yeah, GraalVM and your exactly perfect.
That's good. Yes, people can tweet me. My DMs are open, as they say, right?
Oh, this is really. You shouldn't say that. It will overflow your Twitter client.
Oh yeah, I'm sure. Yeah.
Okay. Thank you a lot.
That was great talking to you
fun.
again, Adam.
Bye.
Yeah, see you.